So you just told me, right, if we have y equals 3x plus 1, and we were to graph this, what does this line mean? What is it?
It's positive.
I mean, it has a slope, but what does it represent? Right? The x and y values that make that equation true. How many x and y values make that equation true?
2.
More than multiple. How many multiple?
3.
1, 2.
More than 2.
Infinity.
More than 3.
As many.
An infinite, right?
Yeah.
Because there's an infinite number of points on this line. So any place I can make a point, anywhere this line continues that I can make a point, is an x and y value that makes that true. Okay. So if that's the case, let's say I graph another line. What does this black line represent?
Other variables?
Okay, a different x and y value that make a different function rule true. Where are both of them true at the same time? Right here. And that's everything that this unit is going to be based on. So when I have 2 equations and 2 variables, my solution is going to be the x and y value, or whatever my variables are, right? If they're a and b or whatever. The x and y that make both true at the same time. The blue line has an infinite amount of ordered pairs. The black line has an infinite amount of ordered pairs. But when I know I need both of them to be true at the same time, that's only happening in one location. Okay, if I need to satisfy both of those rules, well, that only happens once. And there are 3 ways that we can figure out what x and y value make that true at the same time. We can do this by graphing, which is what we're going to look at today. We can do this by substitution, which we are going to look at later next week. Those 2 topics will be on our quiz. And we can do this by solving with elimination. We will be doing that in our week as we lead up into the test before we leave on winter break. Sometimes when we look at different ways to solve, I'm kind of like, oh, just pick the one that makes you happy. This is not that. All right, while they do all work, there's definitely going to be times that one is better over another. And so we really do kind of need different tools in our toolbox for solving them, and we need all of these different options. Now, when we are solving by graphing, which is our focus today, our whole point is going to be just like we sort of said over here, right? We're getting 2 lines, and we're looking to see what happens with them. There are 3 possible things that can happen with 2 lines. Possibility number 1 is that we graph, and we get intersecting lines. Okay, the lines intersect. What does the word intersect mean?
They cross.
Right, they cross. I just want to make sure we are okay with that word. So these over here are intersecting lines because they cross. If the lines intersect, how many times will they intersect? Once. So we will say that if lines intersect, they have one solution. And that one solution is going to be to name the ordered pair. Actually, name the point that they cross at. Whatever that intersection point is going to be our solution. We could also graph 2 lines, and they might be parallel. Okay, so if our solution is where lines intersect, what are parallel lines,
Where they're both like this.
right? They might look like this. Now they could be any angle, but how often do parallel lines intersect?
0.
Never. So how many solutions is this one gonna have?
0.
0, right? This is gonna be our no solution option. We could also graph two lines, and they might actually be the same line.
What do you mean by the same?
So when I graph it, this is my first line, and then I go to graph the second one, and its points fall right on top of it. How many times do these lines intersect? All the time, which is infinite many times.
Infinite.
So this is going to be our infinite many solutions. IMS, infinite many solutions. So remember, I was kind of picky about this before, especially if you had me first trimester, and I would say, no, let's not say infinite many solutions, let's say all solutions, because that was a more specific wording. All solutions means you can pick anything you want to pick, doesn't matter. This does not allow us to pick anything we want to pick, right? A point over here we couldn't pick because it's not on the line.
Yeah.
It's just that there's so many points we could pick. Okay, there's also so many points we can't pick, but there's so many points that we can pick that we can't write them down. There's too many to list. Okay, now at this point, my students are kind of like, okay, what does this actually mean? So let's see if we can tie this together, look at an example, use our knowledge that we just learned about a graphing calculator, okay, and try and make a prediction about what we think the answer to this system is going to be. So grab your graphing calculator again. And kind of set your pencil down for a second. Your calculator is probably going to have fallen asleep. It's going to like turn itself off, so you have to turn it back on. Okay, and now we want to look at this system. What tells us that this is a system?
Y equals.
Y equals.
More than that. Because if we just had y equals like this, that's not a system.
There's 2 points.
There's 2 of them, right? 2 equations and 2 variables. Okay, so what we're going to do is we're going to press the y equals button on our calculator. Okay, we're going to clear out that y equals 3x plus 1, so you can just press the clear button. We don't want to look at that equation anymore because we have a new problem we're looking at. And how many equations does this one have? 2 of them. Okay, so in our first line on our graphing calculator, we are going to enter y equals 2x minus 1.
I forget how to get the x.
So you're going to press y equals, no, you just press your y equals button right here. Sorry. Okay, and then you're just typing in the 2x minus 1. So remember, the x is right next to your green alpha button.
Right here.
Yeah, so we're going to do 2x minus 1.
Should I do it right?
And then once you enter the first one, you're going to press your arrow down to the second line. This one needs to be subtraction. It's negative. Okay, and the second line, we're going to put negative x plus 5. Remember, your negative button is different than your subtraction button. So your negative is below the 3.
Has parentheses.
So now we'll do negative x plus 5.
Can we do negative 1x?
You could type in negative 1x, but it will do it correctly either way. And so you should now see something on your calculator that basically looks just like this. See that? So let me double check real quick. Yep. Okay, now press the graph button, which is way up here on the top. It's gonna take a second, but it's working.
Oh, yeah.
You didn't get your memory before. Why didn't you tell me it was doing weird things, huh? Okay, and again, do we see these two lines on there?
Yep.
Okay, so knowing what we now know, are these intersecting lines, parallel lines, or the same line?
Intersecting.
Intersecting. Intersecting lines have how many solutions? One. And what is the solution? Where they intersect. So now how about you either use your eyeballs or press the trace button and kind of move around and see. It's up to you. You're going to have to like still use your brain.
Okay, how do you
And I want you to guess or tell me what you think the answer of this is going to be. Remember, we're naming the intersection point. That's how we find the solution. So you're telling me what you think that intersection point is. No, just think it in your brain for a moment.
I have no idea. I don't get this. How are we supposed to figure it out?
So we said it's the intersection point.
Yeah, I'm on
Oh. Your problem is right here. Your picture isn't right. You entered this accidentally as a negative instead of as a subtraction. And we need this to be the subtraction one. So now look at your two lines and see if that helps you. Now, can you find that intersection point? Yeah, there you go. Okay, so what do we think? What's our educated guess that we think this answer is going to be? 2, 3?
Yeah, 2 comma 3.
We kind of agree? Okay, so let's set our graphing calculators down for a second, go back to our notes, and now let's look at this problem by hand and see if we agree. See if we can sort of figure out and get the same thing. So what did the graphing calculator do with y equals 2x minus 1? When we put it in there, what did we ask it to do? Right? We asked it to graph it. Do we know how to graph y equals 2x minus 1? Yep, so let's graph it. So where are we going to start?
Negative 1.
Negative 1. And then what are we going to do?
Go up to.
Up 2 over 1. How many points did the graphing calculator make?
Oh,
All of them, right? It went all the way across the graph. So we're going to do that same thing. Both directions. What's wrong?
It's not what this calculator is saying. It gave me that.
What do we have to do with the calculator?
Right here in this one. You accidentally entered this as a negative and not as a subtraction.
Oh, okay.
So this button right here is different than this button right here. This one we only want to use as a negative. This one we only want to use as subtraction.
Oh.
So now let's see if things make more sense now.
Okay.
Is that better?
Yeah.
That was the same thing that Sam was having as a problem too.
Thanks.
Mhm. So now we have this line here.
mm-hmm.
Now here is the good news. Because now what did our graphing calculator do next?
Graphed it.
Graphed what? Did it just stop with one line? Is that what our picture looked like? No, now it graphed the second one. Do we know how to graph this one? Yep, so where are we going to start?
0, 5,
5.
5.
Now, here's the good news. Our graphing calculator does plot every point. We don't need to plot every point. We're going to stop when we know enough because, let's be real, we already plotted enough points.
Mm-hmm.
Okay, so what's our slope on this one?
Negative 1.
Negative 1, so down 1, right 1. Nope, not an intersection point yet. Down 1, right 1. Oh,
Hit.
there it hits. Okay, so Caleb, does that answer your question as to why we need all those points? Because
Yeah.
we need that precise intersection, and we don't know where that's going to be.
Wait, what? I'm confused.
On what? Tell me. I just can't remember. This is good, so you started at 5. And so now we're going to do a slope of negative 1. So here we're going to go down 1, right 1. Now do that again. And see how it intersects right there? You're touching that other blue line. Okay, so our final answer is then going to be to name this point. So what is the name of that point? 2, 3. Is that the same thing we thought we should get?
Yes.
Yes. What does this mean? What does 2, 3 mean?
The intercept? It makes
The number, the point that they both intersected.
We're making progress.
Points that match.
What about them matching?
They hit the same spot.
What did we say the solution to a system was? Go up in your notes.
The
What did we say
point.
this?
The point.
2 equals to
Nope.
They point, they cross at.
No, what did we say the solution to a system is? What did we write down for what is the solution of a system? What does the answer represent?
Oh, it's graphing.
Oh, the X and Y.
Right? The X and Y that make both equations true at the same time. So let's watch this. Is this an X or is this a Y?
X.
So X equals 2. What does Y equal?
3.
3. So let's plug in 2. 2 times 2, so I'm going into this first equation. 2 times 2 is
4.
4. 4 minus 1 is
3.
3. Check.
Mm-hmm.
Now let's plug in 2. Negative 2 plus 5 is
Negative
3.
Positive 3.
Negative 3.
3.
Oh, 3.
Check. So right, both of these are making that equation true at the same time.
Yeah.
Does that make sense?
Uh-huh.
That's what we're looking for. Okay, so let's flip our papers over. Go back to our graphing calculator, and let's again make a prediction on this one. Okay, so we're going to press y equals so we can enter our equations. This calculator does have a place with the ABC button, but I'm going to tell you it's kind of tricky to get to, so we're just going to use the division button for today. Okay, so when we want to enter y equals 1/3 x minus 3, we're just going to do, right, the y equals is already there. We're going to do 1 divided by 3.
Do we clear?
Yes, clear out your old equations.
1 divided by 3.
Okay, so 1 divided by 3x minus 3. Okay, then we're going to go down to the next line. Okay, how am I going to enter this next equation?
Minus 3y.
Yeah, we're going to have to solve this one for y. Is our calculator going to do that for us?
No.
Negative
Nope. You're going to have to pick up your pencil and solve this thing for y. Because the calculator is great, but the calculator still requires the user to have a brain. So we need to solve this thing for y. So I'm going to start solving it for y. Because I can only enter it if it's solved for y. Two negatives make a.
Positive.
So what number's in front of that x?
1.
1/3 x. Perfect.
Plus 2.
So that's going to be the second equation that we now want to enter. Oh, I lost my calculator for a second. Okay, so now we're going to do 1 divided by 3x plus 2.
Mm-hmm. These are parallel.
Okay, yep, so then hit graph.
Why did like red squiggly?
They're parallel.
Well, because you do have to remember that even though this is still an expensive calculator, it still does only have so many pixels on the screen. So you can buy a version of this calculator that's even more expensive, and it's like got a color screen, and it's a much more straight line. But this is just like what we get here at school. This is fine, it does what we need it to do.
Took it to college.
Yes. Okay, so these are parallel lines. And so parallel lines have what types of answers?
No solution.
No solution. So what would we write up here?
No solution.
No solution. We're going to see if we can mimic that. Yep, we got time, so we're going to see if we can mimic that then up here. So if we want to graph y equals 1/3 x minus 3.
Negative 3.
Negative 3 on the y. Then what?
Go up 1
Go up
over
1, go
3.
right.
Up 1 over 3. We're going to graph our second one. Where are we going to start on this next one?
2.
2.
Same.
Yep, up 1 over 3. If I keep going up 1 over 3, am I ever going to run into that other line?
Nope.
No.
Any reason in particular that we notice that makes them not ever cross?
Parallel.
What makes them parallel?
The same slope.
These have the same slope. So lines that have the same slope are parallel and they will never intersect. Lines that do not have the same slope
Always understand.
will always intersect. Okay?
Mm-hmm.
Here's what I want to happen. We're going to finish up this paper on Monday. I didn't figure we'd get through it all. That's fine. So I want you to put this inside